Hello class, today we're going to talk about lesson 5.3, which is rate of change and slope. The objectives for today are that I can find the rate of change and slopes, and I can relate a constant rate of change to the slope of a line. Our first vocabulary alert of the day is rate of change, which is just the ratio that compares the amount of change in our dependent variable, or our y variable, to the independent variable. And we can visually see that right here. Our rate of change is equal to the change in our dependent variable, or change in y, over the change in the independent variable, or the change in x. So let's look at our first example, a consumer application. We have the table shows the cost of mailing a 1-ounce letter in different years. We need to find the rate of change in cost for each time interval, and then during which time interval did the cost increase at the greatest rate. So our first step is to identify what our dependent and our independent variables are. Whenever we're dealing with cost is always our dependent variable, which means then our independent variable is the year. Now that we've done that, we can move on to step 2, which is finding the rates of change. So to do this, what we're going to do is we're going to take the cost, the change in costs, from 1985 to 1988, which means we'll take the 1988 value first, 25, take away 22, and we're going to put that over the years, the difference in years. 1988, take away 1985. Well, 25 take away 22, that's 3. 1988 take away 1985 is also 3, which means our rate of change is 1, or just 1 cent per year. All right, let's look between 1988 and 1990. So we're going to take the cost in 1990, which was 25, and take away the cost in 1988, which was also 25, and put that over 1990, take away 1988. Well, 25 take away 25, that is 0. 1990 take away 1988 is 2. So our rate of change is 0, or no cents, 0 cents change per year. All right, let's look from 1990 to 1991. It cost 29 cents for a postage stamp in 1991. Take away the 25 cents it cost in 1990 over 1991, take away 1990. Well, 29 take away 25 is 4, and 1991 take away 1990 is just 1, so our rate of change is 4, or 4 cents per year. All right, let's do this one more time between the years 1991 and 2004. So the cost in 2004 was 37 cents for a stamp, and in 1991 it was 29 cents. So 37 take away 29 over 2004 take away 1991. Well, 37 take away 29, that's 8, over the difference in years. 2004 take away 1991 is 13 years. So we can call that 8 over 13. Which means our rate of change was 8 over 13 cents per year. So part of the question was to find all these different rates of change. The other part was to decide during which time interval did the cost increase at the greatest rate. So which one of these numbers is greater? 1, 0, 4, or 8 over 13? Well, 4 is greater. So that means the cost increased at the greatest rate from 1990 to 1991. And that wraps up our first example, so let's move on to our next example. So our next example is to graph the data from example number 1 and visually show the rates of change. So let's start by creating our graph. Well, we know that in 1985 it cost 22 cents for a postage stamp, so at 1985 we're going to go just above or just between 20 and the next box. Because on my y-axis, I went up to 20. This little squiggly line allows me to do that. And then I went, each box was 4. And then I labeled every 10. So we've put the first point. Let's put our next point. In 1988, it cost 25 cents. So every 2 boxes on my x-axis, I went by 5s, which means 3 years later is just between the next 2 boxes. So we'll put a point right about here. And then in 1990, it also cost 25 cents. So at 1990, we'll put a point about here. Then, in 1991, right after 1990, the cost went up to 29 cents. So we're going to go just shy of our 30-cent mark. And then, all the way in the year 2004, the cost went up to 37 cents. So we're going to go almost to 40. All right, now we're going to connect the dots, going the first dot to the second dot, and then to the third, and then to the fourth, and then all the way up to our 5th dot. And we have finished example 2, where we graph the data, but now we're going to actually visually show that we had to go up 3 and over 3. So we had to go up 3 in our change in cost and over 3 in our change in years. Then there was no change from 1988 to 1990. But we did increase 4 cents from 1990 to 1991. And then finally, we increased 8 cents and 13 years between 1991 and 2004. So we have graphed the data and we have visually shown the rates of change. So let's move on to our next example. In fact, before moving on to our next example, let's talk a little bit about slopes of a line. So we have the rise is the difference in the y values of our 2 points on a line, and the run is the difference of the x values of our 2 points on a line. The slope is just then the ratio of the rise to the run for any 2 points that are given on the line. So the slope is just the rise divided by the run, or the change in y over the change in x. So remember that y is our dependent variable and x is our independent variable. So given this graph that goes through the points 1, 1 and 2, 3, we are going to find the slope of it by looking at how much it rises up and how much it runs over from one point to the next. So from our first point, 1, 1, we have to rise up 1, 2, 2, and then we have to run over 1. So our slope is the rise, which we said was 2 over our run, which we said was 1, and 2 over 1 is simply just 2, which means the slope of this line is 2. Now we can also look at it the opposite way. So instead of rising up, we can look at how we rise down, which we have to rise down 2 units. And we have to run over 1 unit. So this rise was positive 2 over positive 1. This runs down, so it's a negative 2 over, it runs to the left, negative 1. So the slope could also be thought up as negative 2 over negative 1, which will still simplify to give us 2. So that's the end of the third example. Let's move on. So let's look at the slopes of horizontal and vertical lines. Well, in our horizontal line in example A, there is no rise. So our rise is 0. Our run from one point, negative 1, negative 1, 2 to 3, 2 is 4. So it's 0 over 4, which means that the slope is 0. That is the case for all horizontal lines. All lines that are horizontal have a slope of 0. If we're looking at a vertical line, where it goes through the points negative 2, 3, and negative 2, 1, our rise is 2 over, there is no run here. We don't go left or right at all. So our run is 0. We can't divide by 0, so we call this slope undefined, or just UND for short. All vertical lines have an undefined slope. All right, let's move on. So here we just have a little graphic about the different types of slopes. If from left to right we're moving uphill, we have a positive slope. If we're moving from left to right, we go downhill, then we have a negative slope. All horizontal lines have a 0 slope, and all undefined slopes are from vertical lines. Now you have seen a picture on my desk called Mr. Slope Guy. Let's take a look at what he looks like. Alright, let's start with Mr. Slope Guy's eyes and eyebrows. So on the left side of his face, from moving left to right, his eyebrow is going uphill. Mr. Slope Guy has a positive eyeball. And then on his right eye, he has an eyebrow going downhill from left to right. He has a negative slope. His nose is a vertical line with a U underneath it, meaning it has an undefined slope for vertical lines. And then his mouth has what we could call 2 circles or 2 dimples on either side that look like zeros. That means his horizontal mouth has a 0 slope. So now let's look at our next example, which is just looking at a picture and deciding, is the slope of the line positive? Is it negative? Is it undefined? Or is it 0? Alright, so I've gone ahead and I've drawn Mr. Slope Guy between our 2 examples, so we can just look at Mr. Slope Guy's face and look at the picture and decide if it's positive, negative, 0, or undefined. So, A, we have a line that looks like it's going downhill, and a downhill line on Mr. Slope Guy's face has a minus sign next to it. So we can say the slope of A is negative. Alright, let's look at B. B is just a horizontal line. If we look at Mr. Slope Guy's face, The horizontal line on his face has two dimples that look like zeros, which means that the slope is 0. And that's all we have to do for those examples. So we're done, but let's look at a picture or a graphic where we can look at how slopes are compared. So we have 3 graphs here. All of them have 2 lines on them, and each line has a different slope. So in the first picture, we have a line that has a slope of 4, and that slope is steeper than the other line, which has a slope of 1/2, because the absolute value of 4 is greater than the absolute value of 1/2. In our middle picture, we've got 2 lines again, where one line has a slope of -2, and the other has a slope of -1, and the line with a slope of -2 has a steeper slope because the absolute value of -2 is bigger than the absolute value of -1. Then we've got a final picture with 2 lines, and one of the lines has a slope of -3, and the other has a slope of 3/4. Well, because the absolute value of -3 is bigger than the absolute value of 3/4, the line whose slope is -3 is steeper. All right, that wraps up our lesson 5.3, rate of change in slope. For the rest of the evening, I want you to do the your turn problems before you get to class tomorrow, and I will see you later.